So this is our second problem, and it's called cost. And basically, you're given an undirected graph where each edge has a weight which is distinct from the others. So for example, we could have this graph with an edge of weight 2 and an edge of weight 3. And what the problem asks from us is to calculate the sum of a certain cost yet to be defined between all the pairs of nodes. So what is the cost between a certain pair of nodes? It's calculated as follows. So let's suppose that, for example, we are taking this and this node. We want to know the cost between them. So we calculate the cost by removing edges from the graph until the two nodes are disconnected from each other. And we remove the edges in increasing cost. So for example, suppose we have these two edges and we want to calculate the cost between these two nodes. We would first remove this edge, which would already disconnect the two nodes. So the cost between these two nodes is 2. But, for example, if we were to calculate the cost between these two nodes, then we would first erase this edge, giving us a weight of 2, but there is still a path between the two nodes. So we would also need to erase this second edge. And that would give us a total cost of 3 plus 2, which is 5. So suppose we have a more complex example in which we have two paths. So let's suppose the costs are 1, 2, 3, and 4. So if we take this pair of nodes, this one, first we would remove this edge, but there is still a path between the two nodes. And second, we would remove this edge. And then the two nodes would be disconnected, and we would have removed two edges, and the total weight of them is 3. So the cost of going from this node to this node is 3. But if we were to calculate the cost between, for example, these two nodes, we would have, in order to disconnect them, we have to remove all the edges of the graph. Because we remove them in increasing order of weight, we would first remove this one, then this one, and then this one, but there would still be this direct edge. And we would finally disconnect the two nodes when we remove this last edge. So the total cost, the cost between this pair of nodes is equal to 10, which is the sum of all edges. And what the problem asks from us is the sum among all pairs of nodes all distinct pairs of distinct nodes, unordered pairs, of the cost of going from U to V. So basically, this is what the problem asks for us. So in this case, we have 3 pairs of nodes, this pair, and this pair. And we already calculated the cost for this pair, it's 2. So in this case, the answer would be 2, plus the cost between these two nodes, which is also 2, we only have to remove this edge, plus 2, plus the cost between this pair of nodes, which is 5, because we have to remove both edges, plus 5, equals 9. So for this test case, the final answer we would have to print is 9. So yeah, basically that's the problem cost.